This is Mayur. Welcome to ML Works. This video will be talking about pandas. This is the second video of the series, and this will be a little more in depth compared to the first video where we just went to what some basic functions on top of data frames. Here we'll be using some columns, start working on the columns part of your data frame, and let's get started. So just first we have to import the pandas library, import pandas as PD, and then we are reading a data set, internet data set, and using dot read read underscore cv, and then we are just doing the dot head function on top of the data frame to just look at the data. Actually, what are the kind of columns we have, what kind of data it is storing. Okay, so we have like around like 10, maybe probably 10 or 12 columns we have, and this is an unnecessary column which got generated here. So basically, when we are saving a CSV file, right, in the pandas, if we are not giving some ignore index, okay, it will generate, and while saving the CSV file, it will generate such an index, actually unnamed :0 index is generated automatically. So what we should do is, while saving the CSV file in pandas, you have to give ignore index, so such that it will not generate this kind of unnecessary columns. So since we have this kind of column here, we have to remove it. So what we do is, we have something called as dot drop. Okay, and here we give the column name, and this is the axis we have to mention. It is like vertical and horizontal axis, like columns or rows, and in place is equal to true, meaning it will permanently remove what from data. Actually, in place removal will happen on the data frame. Okay, so let's run this, and we can see that unnamed :0 is removed, and now we have our data set here. So let's see, just a bunch of things we'll do in the next cell. So if we see here, first we'll check all the columns name we'll identify using dot columns, and then we'll find what is the total number of records present, total number of columns using data dot shape, and then we'll look at the kind of index we have, such that this index will help us in what locating some particular record. So then we have something called as dot d types, which will give us the data type of our columns. Okay, let's run this. So these are the columns we have. First and foremost, country code, country, continental region, speed, internet user, population, average price, 2021, 2020, cheapest 1 GB for 30 days. Okay, so total number of plans. Okay, so this is the number of columns we have. Total number of rows are 243 rows, and 12 columns we have, and the index is a numeric index. It starts from 0 to 243 and at a rate of 1, and D type is data types. So majority of them are objects of type objects, and a few of them are of float 64. Okay, so next what we'll do is, since we have this float 64, sorry, float 64, will apply what some basic mathematical functions on these kind of columns. So for that, what we have to do is, just we have to do something called as data.describe. It will automatically fetch these columns, right? Number of internet plans, cheapest 1 GB for 30 days, and most expensive 1 GB, and then we have something average megabits per second. So this is the describe. We'll get the basic math idea here. Like, we have total of 231 records. Okay, so here if we see, we had 243. Okay, so number of rows, but if we are seeing here, it is totally 231, meaning 13 of the records are not present or not available or any end, and mean is equal to 26 point. This is the number of internet plan. This is the cheapest. So if we see, the most expensive 1 GB USD is $768. Okay, wow. Minimum is $0.63, and average speed is mean is 37 megabits per second, minimum is 4.8 megabits, and maximum is 135 megabits. Okay, so if we see this quantile range, okay, 75% of the records, almost 75 percentage or less will have what less than 49.66 MB megabits per second on an average. Okay, so we get this idea from this dot describe. Next, what we'll look at is, yeah, as earlier, right, we have NANs present. So we'll see what is the total number of NAN present for each column. So for that, we have to do dot data dot is NA dot sum, and we'll see total number of NAN. So in average megabits, we have 112 records, population 32 records, 30 internet users 30 records. So 12 records are not present for this most expensive average price, and then number of internet plans 12. For 12 countries, we don't know what is the number of internet plans. Okay, I think this will be in correlation, all these records, right? All these 12 records will be in correlation, because since you don't know number of internet plans, you cannot also know what is the cheapest one and all those stuff here. Okay, now let's see how to find out the top largest of some column, n largest of some column. Okay, n largest of like top 5 and average megabits per second. So top 5 records we'll see. So which 5 countries has highest speed? I guess this is speed right here. So we have Saudi Arabia, and then we have Norway, then we have Qatar, South Korea, and wow, Netherlands, Aruba. So all these 5 countries have the highest speed with respect to what internet speed, and we are doing what n largest on top of it. Similarly, we can do something called as n smallest, which will give us what which countries has the lowest speed internet speed. So if we do for that, we just have to do dot n smallest, and we'll see what are the countries. So here if we see most expensive, this is the most expensive. Okay, since we have NAN, okay, though we are getting some what messed up values here, so we have to remove those things. Most average speed, okay, here is the average speed we have. So 4.89, okay, that is 1 megabits, okay, 5.5, 5.68. So which countries are these? Okay, this is mostly what Asian countries and what Afghanistan, Palestine, Middle East. Okay, we have in Somalia one, Tajikistan and Venezuela. Okay, wow. So see, if you see in this column, right, average price of 1 GB USD is hyperinflation. Wow, for Venezuela. Okay. So this is something we have to what keep in mind while we are doing data analysis, right? So why we don't have this value here? Okay. Next, what we'll see is applying an aggregate function on the columns. Aggregation is what it will group the records and try to identify what kind of function you can apply on top of that group. Okay. So for example, here I'm using data.aggregate. I'm applying functions like max and min, okay, on grouped data. So if you see here, we have these columns, right? Country and country code. So which will have will apply max on this kind of column, each of the column, and min on each of the column, and we'll find the value of those. Okay, so if we see here country code Zimbabwe, okay, that is the max because of the alphabet actually, and the minimum is AD, and AD I don't think it is Afghanistan, this is something else, I guess. AD is some other country. And country wise, if you see, Afghanistan is the min and this is max, and this is not a ordinary A letter, right? This is A dot something on top. Okay, so we'll also see what is the most expensive GB, most expensive 1 GB USD, cheapest 1 GB for 30 days. Okay, which country? This is 0.00. Okay. These are things we have to notice. What is this 00? It's not possible some country will what give you 0.00. Okay, so this is something we have to take care of. And the number of internet plans, okay, they have one internet plan. Okay, so we got this using aggregate function or max and min on each column. And if you see, right, there are some things which I noticed here in the column names. Okay, so there will be a normally we won't look at the columns names in depth. Okay, but there might be some columns which will have what extra spaces, so we want to remove those spaces. For that, what we have to do is data.columns it of type string, and then we have to apply strip function. It will strip off the spaces on both the side of the string. Okay, let's see. For example, if you see here in the column number of internet plans, there is an extra space is present. Okay, so we want to what remove that. So what we do is we apply strip function on top of it, and then we what get something like this, number of internet plans without space. So we are just manipulating our column names using these functions here. Dot strip, you can do something, replace anything you can do actually. Those kind of yeah, this is easier actually when you want to do what removing spaces and all. Okay, next what we'll do is, since we have our word speed in bits, okay, what we'll have to do is we can convert into bytes. Okay, for that what we have to do is just data of that column name divided by 8, and then we are directly applying whatever the value that got changed, the bits to bytes, we are again pushing it to the same column name. Okay, and now since we have changed it to megabits to megabytes, we can rename the column using dot rename. Columns is equal to this column name is changed to this column name, and we are doing in place is equal to true. On the data frame we are applying it actually. Okay, let's apply this one, run this thing. Okay, let's check data dot columns. So if we see, it will be megabytes now instead of megabits. The column name is changed and megabits is removed, so it got replaced. Now what we'll do is filter rows based on the numeric condition. Okay, so if we have a column with what floating point or integer, right, we can apply all this numeric condition, less than, greater than, less than, equal to, greater than, equal to, on top of the data directly. So for that what we have to do is data of data and the particular column you have to apply the condition on, just do lt, which is less than 1.5 megabytes, and we are just looking at the top 5 records dot head. Okay, so if we see here, we have applied megabits less than 1.5, so we are getting all the records 1.58, 1.18, 1.3, 1.24, 0.99. So this is one, and there is similarly we can also do what greater than. Okay, greater than 100. Okay, average expensive. Okay, most expensive 1 GB USD rate. So if we see here, then we have all these records, which is France has what $118 per GB, most expensive. Okay, Mali, Saint. Okay, so instead of this one, right, I'll just do head. Okay, just 5 records. Okay, Caribbean island has man expensive. These are expensive plans. Okay, Western Europe $163. Okay. So we can do what? Just data of data dot greater than of 100 whatever. This is what will happen is this will generate a true or false on for index. By index it will generate true or false. Okay, and those wherever it is true, those records will be shown. Okay, when you apply this condition, right, on the data frame dot greater than 100, you will get a list of what a series of true or false. Those series is pushed into what data frame, and it will fetch those records and what display it. Just let's try to do, like, if we can do that, right, let's check once. Yeah, so as I said, if you see the right greater than 100, it will generate true or false. The records which have greater than 100, then which will appear as true. Yeah. So if you see index 10, this is the index 10. Okay, now what we'll do is, if you see all this in the earlier cell I have shown the data types, it is mostly objects, even for what population. If you go back here, not here, okay. So if you go back here, this population, internet users, all these are objects actually. Okay, it's not of type integer or float, so it cannot be float for sure, but sure, for this thing, right, it should be what, integer. So since this is an object type, if I go and what look at each of the record, okay, if we go and look at each of the record, we'll see something else actually. One sec, let's run this. So I'm looking at one of the data point, okay, of internet user, and it is of type class string. So since this is a numeric value and it is represented as string here, we have to convert that string into what, float or integer, to work on it, this data, to manipulate or to find something out of it, right? So we have to what, convert it into integer or float. So for that, what we have to do is we have to do something called a data of internet users dot string dot replace. Okay, so first we are removing the comma, okay, and replacing it with nothing, empty thing, and then we are applying this apply function on top of this column and writing in what, anonymous function. And then in that anonymous function we are also what, doing a condition, if condition, and checking if the instance is of type string, okay, then we want to convert it into integer. Otherwise I'll just what, pass it a we are good man. Okay, so this is also what, this is just for time pass. Okay, this is, we'll do what, another cell will try out, actually we'll clean this thing up. So let's apply this one. This is pretty little complex actually. So we have to first replace comma, and then we have to apply a function, and inside that function we have what, we're checking some conditions, and based on that condition it will what, apply either if or if, either it will apply else. Okay, so let's run this cell. Now let's see what is the data type of that internet user we saw, right? Earlier it was string, now it is of type int. Okay, now this function which we saw, right, this is it doesn't have any what function name. This is called as anonymous function. So since here I am what, converting into string, right, this is an integer, I'm also adding some string here. Okay, so wherever the what, nan is present, for instance, all the value, consider this, it has what, 12 nans. Okay, this particular internet user has 12 nans. Okay, wherever it finds in string, okay, it will convert into integer, and wherever it finds nan, it will convert that into what, we are good man. Okay, so now what we'll do is we'll convert this we are good man into what, some other value which is compatible for what, our manipulation, data manipulation. So let's go to what, apply anonymous function on column. So this is internet users we have applied on, and let's see. So data.internet users dot apply lambda x. If this instance is integer, we don't have to do anything. Okay, since it is already integer, okay, we don't have to do anything. Otherwise we have to convert it into 0.00. Okay, so if we see here, we have converted what nans has we are good man. So what I'll do here is, since it is of type what, string, and not of int type, it will get converted to 0.00. Okay, now let's see. Okay, so this is the total number of users we have, internet users. Okay, it's some number, and it's, I can't read this one. Okay, and let's check like what, if we have 0.00, right? Okay, data of internet users value counts. Let's see. Yeah, so there are around 30 records, okay, which is whose value is 0. Okay, this got inserted because of this one. We got this value because of this one, 0.00. Okay, fetching records using conditional statements. So here what we'll do is we have a column, and we want to what, fetch particular record based on some condition. For example, I want to get the maximum country, okay, which has the maximum number of internet users. So I am having this condition here, I'm fetching the maximum value of internet users, and I'm applying this condition here, and then we'll see the record which got fetched. So if we see here maximum internet user, if we see we have China, and there are 36 plans, and what is the population and internet user? Okay man, this is also 10 power 9. Okay, so these are so many users we have actually here max. Okay, and average speed is 10 megabytes. Okay, super. Now we'll see, like we'll again apply some other condition also. So here we applied like data internet user is equal to data of internet users dot max. So we can also do something called as data of what internet user dot greater than whatever this is, 1 billion I guess. Okay, 1 billion or 10 billion. So we have countries like what internet users: Russia, Indonesia, China, Pakistan. Okay, so many users we have actually. So wow, India is also present, Brazil, United States. Nice. Okay, this is one way to what fetch records based on condition. There is also this condition. Okay, this also we can do. Okay, next. Okay, since there are like two columns, right? We have something called as population also here, and also internet users. So we can do something called as correlation, if we can see if these two columns are correlating or not. So again, population is also what of type string. So we are replacing that comma into what empty string, and then followed by checking if it is of string type. Then we are converting into an integer. Otherwise, we are replacing that nans with 0.0, and then just applying it on top of population directly. Okay. So once this is done, then we check the correlation of this population with internet users using cor function .coor. Okay, so if we see here, we have what, 100, almost 100% correlation actually. Okay, so this is one thing. And next here we have removing parentheses. So if you notice here, right, in one of the columns, these columns, into what continental region, I guess this is. Okay, so we want to what, remove this whatever is present inside the parenthesis. Okay, so what we can do is we can apply directly regex on top of the column actually. So what we can do, something called as replace. We have the string, we have replace function for the string, and then we apply something called as regex function, where we are looking for whatever content that is present between the braces to be replaced by what, empty string. And this is, we can give this regex is equal to true. This is just for understanding actually. This, you, even if you don't give, this will work out. Okay, let's apply this, and we'll see what is the columns now. Continental regions, so all those words are removed, whatever present in the parenthesis, right, those are removed, and we have some bunch of continental regions. Okay, head. So we don't have any more actually those words present inside the parenthesis. Okay, I guess I'm almost done with this video actually. So we have seen a lot of stuff: correlation, removing parentheses. Okay, using regex on top of what, data frame, and then we also saw something called as conditional statements inside the data frame. Okay, then we applied anonymous function, and we converted string type to integer or float using lambda and this instance. Okay, then we have seen a lot of stuff actually. Okay, and probably I'll go much more deeper in the next video. Thank you.